Good morning, everyone. Praise be Jesus and Mary. Welcome to another lesson for Calculus 2. But before we start, Miss Guzmana, can you please lead us for our opening prayer? Thank you very much, Miss Guzmana. So let's see in our Google Meet if everyone here is present. It looks like everyone here is present with all 8 math majors being here. So congratulations everyone for being present for another day for our lesson. But before we start, uh, let us first remember what was our previous topic. Mr. Alpuerto, can you please recall what is our previous discussion? Yes, it was all about integration by substitution. So let's now dive in on what is our new topic for the day. But before we go through that, let's have first an activity called Differential Connections. So our directions, as you can read, that under the product rule in differential calculus, determine the correct derivative for each given equation. The group with the most points at the end of the activity is the winner. So how do we do this? I will let you answer through multiple choice individually, and later we will accumulate the points for each group. So as I said, the most points will be our winner. So who are your group mates? For group 1, we have Mr. Alpuerto, Mr. Bello, Ms. Evangelista, and Mr. Tohong. For group 2, we have Mr. Oges, Ms. Guzmana, Mr. Lumanog, and Ms. Zambrano. So on that, let's start. So the derivative of x to the power of e to the power of x is equal to which of the following? Time starts now. Time is up. The correct answer is letter C. Congratulations everyone, all of you got the correct answer. So that means we have 4 for each group. Let's go further to the second question. The derivative of x cosine x. What is its derivative? Start. Time's up. It looks like we have differing answers. Let's see. The correct answer is letter A. So sadly, for group 1, we have 2 correct answers only. And for group 2, we have 3. So that puts our total by 6, 7. Let's go to the third. So what is the derivative for the following factors? X plus 5 and 3x minus 2. What is its derivative? Time's up. The correct answer is letter B. Congratulations everyone, all of you got the correct answer. So that means we have a 10-11 score. Therefore, I congratulate the second group for winning our little activity. So a round of applause everyone. So let's go further. So what do you think is the rule used in this activity? Mr. Tohong? Yes. As I've mentioned earlier, this follows the product rule of differentiation. But Mr. Tohong, why do you think I brought this rule in differentiation? Yes, it could be that it correlates as like the other differentiation rules. So let's try to expound on that. So what truly is this? So our topic for the day is called integration by parts. So like the integration basic rules and integration by substitution, this is another strategy for us to deal with integrals. So let's see. Let's see our objectives for the day, which are the following. At the end of the 90-minute discussion, the students will be able to, boys, please read the first one. Girls, please read the second one. Third, everyone please. Thank you very much. So we will go through all of those objectives little by little in our discussion. So the product rule and integration by parts is, as mentioned by Mr. Tohong earlier, that it is the reverse, or at least corresponds to the differentiation of the product rule. So for the basic rules, like for the example here, the derivative of x is equal to 1, and the integral of dx is equal to x. Those are just the same, and all of the basic rules are just equal. It is just reversible. For the differentiation chain rule, we have the integration by substitution. We can even see that in our substitution of the u variable in order to make the equation more simplified in a way to get the answer quickly or in a manageable manner. But for the differentiation through product rule, we have integration by parts. But why so? Let's try to see. So how can you, do you remember what is the equation for our product rule? Ms. Zambrano, can you mention what it is? Correct. Our product rule is defined through this equation, that the derivative of uv is equal to u dv over dx plus v du over dx. So how do we manage this, Mr. August? We can do it algebraically to get the equation for the integration by parts. Yes. How so, do you think? Yes, we can first go through with the cancelling of the dx, since everything is dx is a common term for each of these equations, and it will just cancel each other out throughout the equation. So we have this now. So how do we further this? Anyone in class? It seems no one. So we can go through that through simple manipulation. Let us isolate this u dv. Why so? Since this correlates to being this will be our basis for our product rule. I mean integration by parts rather. So we isolated u dv and transferred, or through addition property, we have now u dv is equal to d multiplied by uv minus v du. What do we do next? We integrate both sides, and by addition rule we can separate the two. But in this case, this d and this integral will cancel each other out. Therefore, we have arrived with our integration by parts equation, which is the integral of u dv is equal to uv minus the integral of v du. So what is in this case our u? So our u can be determined through an algorithm of sort. So the first thing that we will consider is that is it a logarithmic function? Which of the following parts in that equation or integral is a logarithm? Pardon me, Mr. Burp. If there is no logarithmic function, then we can go through the second one, which is the inverse trigonometric function. So this might be in the form of arc sine, arc cosine, or the like, or even those with trigonometric functions with the exponent of -1. If there is none of those as well, we can proceed to the polynomial functions. So this can be just solely a single variable, such as x, or even a quadratic function or a linear function or of the such. Then, if none, we can go through the exponential function. So, examples of this is e to the power of x and such. And lastly, if there is none other else, then it might be a trigonometric function that will be subjecting to the integration by parts. So our consideration or the algorithm for finding u is through the acronym LIPET. Logarithm, inverse trigonometric functions, polynomial functions, exponential, and trigonometric functions. So you may ask, what is dv? What is this? So dv is what's left of the integral. What's left of the given integral. For what is v, our v will come from dv. That is the integral of dv. But what is du in this case? Du is the differential of u, and then we isolate du. So sir, you may be asking, how do we apply all of this knowledge? Let's try it out with our first example. So our first example here is that the integral of x cosine x dx. So as you can see here, our equation is like this. You can't really solve it immediately with basic integral rules. So let's first determine our parts. Mr. Belio, what is u in this case through LIPET? Yes, it is a polynomial function, which is x, correct. Mr. Ogis, what is the derivative of this u variable? Yes, it is du over dx is equal to 1. It's the derivative. So then, if we isolate that, we get its du, which is equal to dx. So we just cross multiply that, which resulted to du is equal to 1 dx. 1 dx is still dx. Ms. Guzmana, can you tell us what is dv in this case? Yes, dv is the remainder, which is cosine x dx. Miss Evangelista, can you tell us what is our v? Our v is equal to sine x. We already know that through the basic integration rules. So let's now go through in solving this. Let's put up the formula for this integration by parts, which is uv minus v du. So we plug in our values here. So u is x, v is sine x, minus the integral of v, which is sine x, then du is dx. As simple as that. We can then find the integral of this part, which is negative cosine x through basic integration rules. And don't forget to add the constant. Then we can simplify that further by turning that into a positive sign. So that is the final answer. The integral of x cosine x dx is equal to x sine x plus cosine x plus c. That is the final answer. Do you understand? Any questions from the group? Okay, good. So let's go further into the topic. So integration by parts, how do we use this? If there are other strategies with the basic integration rules and the substitution. So what we can do here is by following this flowchart that I've created. So ask yourself, can you use basic integration rules in the given integral? If the answer is yes, then use basic integration rules. As simple as that. If no, ask yourself again, can I use integration by substitution? If that's the case, then use integral by substitution. As simple as that. We have already known the details in using integration by substitution and what are the conditions in order to use it. But if we can't use integration by substitution, then what exactly can we do? Ask yourself again, is it made up of two factors? Two factors meaning by being a product of some sort. It will create a product. If yes, then use integration by parts. So these are your considerations. There are more strategies further down the line in answering or finding out intervals, but we will head to that in later parts of our discussion for this subject. So, do you understand the conditions that we have for integration by parts? Okay, yeah. Yes, I'm hearing all positive remarks. So, let's go for another activity, which I call integrating with the flow. So our directions here is to determine if the following integral should use integration by parts. If so, determine the value of u. Likewise earlier, our groupings will be applied in this activity, though this will be more points based. So let's see if you got the gist of our flowchart. And likewise earlier, there is a 5-second rule. So, should you use integration by parts for this integral? The integral is x squared plus 1 multiplied to 2x dx. Start. Raise your answers if it's yes or no. The answer is no. Congratulations everyone, you've got the correct answer. So basic enough. The reason here is the following. We can just simply use the basic integration rules. We can have that, or we can multiply, and then 2x cubed plus 2x dx, and then we can separate that through the addition rule, and further down the line we can use the basic integration rules, and we have this. Second question, the integral of 2x cosine dx, should you use integration by parts for this integral? Answer? The correct answer is yes. Congratulations everyone. Once again, you have provided the correct answer. So, in this case, what is u? Okay, let's see the Google Meet. Everyone is correct. The answer is 2x. So why so? Why so can we use this? Mr. August, why do you think? Yes, the two strategies can't be used. And also, there are two factors here. So let's try to solve this. Mr. Bellio, what is u and u in this case? Correct. Our u is 2x. Sorry for the typo there. That is 2x. And our du is 2dx. Miss Evangelista, what is our v and dv? Correct. Our dv here is cosine dx, cosine x dx, and v is equal to sine x. So let's start by integrating. Everyone, can you try to solve this? Yeah, let's see everyone. Okay, so please check your answer. So we have now we have to plug in our values. And now, through the basic integration rule, we have negative 2 cosine x, which in this case we took out 2 since it's a constant. Then we had the remainder of sine x dx, and now we have negative cosine x multiplied to 2, and thus we have this. Then we can simplify further by 2x sine x plus 2 cosine x plus c. Very good, everyone, that you have gotten the correct answer for this integral. Let's go to the third. X cubed ln x, the natural logarithm of x dx. Should you use integration by parts for this integral? Go. The correct answer is yes. So congratulations, everyone. Then let's go further to the next question. What is the u in this integral? The u in this integral is the natural logarithm of x. It seems that some have mistaken the answer. So why so? Mr. Lumanog, can you please remind the class why ln x is our u? Yes, it was dictated by the Lipet rule that a logarithm will go first or has priority in being identified as the u variable. So let's try to answer this. X cubed ln x dx. Mr. Lumanog, can you please continue what is our du? Our du is 1 over x dx. Correct. Then, Miss Zambrano, can you please tell us what is v and dv in this case? Correct. Our dv is x cubed dx, which is the remainder, and v is x to the power of 4 over 4. So let's try to solve this, everyone. Okay, it seems everyone is already done. Let's see. We have now the solution x to the power of 4 divided by 4, natural logarithm of x minus the integral of x to the power of 4 over 4 multiplied by 1 over x dx. Let's do some tricks here. So since 1/4 is a constant, we remove that out. That remains us with x cubed. Why so? Mr. Alberto, why so? Yes, since it cancels them out, remaining x cubed. Then we can now further do basic integration rules. With the following, we have x4 to the power of 4. Multiply that, we have x to the power of 4 over 4 ln x minus x to the power of 4, over 16 plus c, which is correct for everyone in the class. So let's try the fourth one for this activity. The integral of dx over 3x minus 8. Should you use integration by parts for this integral? Go. It seems that everyone has answered no. Is it the correct answer? It is the correct answer. Congratulations, everyone. But why so? Can you answer? Can you answer, Mr. Belio? Yes. Aside, it is a rational function, and at the same time, we can use the other strategies, such as, Mr. Belio, can you continue? Why? Yes, through integration by substitution. So, that is it. We had u substituting 3x minus 8, 1/3 du, and then we can put out 1 over 3, integrate 1 over u, and by the basic integration rule, we can have the natural logarithm of absolute u. Substitute that back to 3x minus 8, and we have this answer. Let's head to the fifth one. The integral of sine squared x cosine x dx. Should you use integration by parts for this integral? Should you use it? The answer is unanimous for everyone, which is no, which is the correct answer. So why so? I think we have already tackled this as a previous example in our discussion for for integration by substitution, which in this case, our sine x is our u. Substituting all of that, and our dx du is over minus cosine x. Cancel that out, and we have negative du. Multiply that out. Since negative can be interpreted as negative 1, so move that out. It is a constant. And now, integrate that u squared to u cubed over 3, negative, that is negative, plus c. And put back the substitution to sine cube x over 3, which is correct in this case. So let's try another example. We've already done with our activity. Congratulations, everyone, for doing a job well done. So I'll put that in our records. So our second example is the integral of x squared minus x cosine x. Seems simple enough. So Ms. Guzmana, can you tell us what is the u and du for this equation? Yes, our u is the polynomial x squared minus x, and its du is 2x minus 1 dx. Mr. Tohong, can you tell us what is our v and dv? Our v and dv is correct, as you have said, cosine x for dv, and for v we have sine x. So let's try to put that into our equation. Let's try it, everyone. Mr. El Puerto, you're raising your hand. Yes, it seems to be repeating. Let's see our example here. X squared minus x sine x minus sine x 2x minus 1 dx. Now, in this case, our integral seems to be fitting for another integration by parts, which is repeating our simplification process of integration by parts. So it's self-defeating. So in this case, we are to try integration by parts again. But that could be tedious since sine x would return to negative cosine x. And negative cosine x would result into negative sine x. And negative sine x would return to cosine x. And cosine x would go to sine x. It's everything cyclical at this point. So what do we do when this happens, as Mr. Alberto has pointed out in the cyclical pattern of this integral? So what do? We use tabular integration. So this is technically a subpart in our integration by parts. So we follow this format: p of x, f of x, dx. So first step is to differentiate p of x repeatedly until you obtain 0 and list the results in the first column. So in our case, x squared minus x is our u, or the first part. Then 2x minus 1 is its first differentiation, its first derivative. Its second derivative is 2. Its third derivative is 0. So we have reached the end. So let's head to the second step, which is integrating f of x repeatedly and list the results in the second column. So we stop until the 0 point of p of x. In this case, cosine x becomes sine x. Integrating that, negative cosine x, and turns into negative sine x at the end. So our third step for tabular integration is to draw an arrow from each entry in the first column to the entry that is one row down in the second column, like this one. So what do we do here? For the next one, label the arrows with alternating positive and negative signs, starting with a positive sign. So x squared plus x multiplied by positive sine x, then 2x minus 1 multiplied by negative cosine x, and 2 multiplied by positive negative sine x. So that is our three terms to remember. So number 5, from each arrow multiply p of x to its corresponding f of x, which we did earlier, with accordance to the arrow sign. Add the results to obtain the value. So we have already mentioned these following. And don't forget to add the constant. So we simplify this by, since there are 2 sine x here, these are common terms. So move that negative 2 here and group them together, plus 2x minus 1 cosine x plus c. That is the final point for our tabular integration. So we can use that when, if ever, we encounter a cyclical pattern. Like for example, like it could also be used in e to the power of x, since our integral for that is just repeating e to the power of x, e to the power of x, and so on and so forth. It's just the same. So, does everyone understand here so far? Very good. Everyone seems to be affirmative on that. So let me ask you, how does integration by parts help in solving integrals? Mr. Alpuerto, how does it help? Yes, it provides ease into our topic of integration, since there are various circumstances in integrating in doing integrals. So in this case, our by parts is akin to these puzzles in our design here. We are doing it by parts. From that, how about to real life application? How does it help? Mr. August. To real life application, yes, you can say that as you can relate it to the puzzles that I've mentioned earlier, yes, it provides some sort of ease by doing something in parts, by not chewing too much more than by not biting too much more than you can chew. For what furthermore answers, Miss Zambrano, what do you think? Yes, in our task also, you can apply the value of this integration by parts by little by little doing your task as well. Can we relate that to the issues of our current day society right now? Mr. Lumanog, can you think of some? Yes, with our politicians, you can definitely say that. Since if a leader can't really delegate the job, it's either he's just an individualistic person, or either he's just a boss and not a leader who inspires his or her people. So that is one of the things that we are watching out now for the current elections. So that is exactly what our integration by parts here is doing for calculus, and also for the value here in applying it. So as we can think of it, the Bible says it well, that watch out that you not lose what we have worked for, but that you may be rewarded fully. So as we did it by parts here in our integration by parts method, we did not lose track of what we are trying to solve. Since we had 4 parts, u, dv, v, and du. And by little taking that up, we had our correct answers. We are then rewarded fully. And at the same time, you can apply that value to our lives, as we have mentioned earlier, with working by parts to do something effectively, and for those that we see in our society. So does everyone understand the value of this integration by parts? If so, let's do a quiz for everyone to understand. So solve the following integrals using integration by parts. You have to do this through the direct method or tabular integration. Write your answers and solutions in a short band paper. And please take a picture of it and send it to our Google Classroom. I have provided there a part in our stream for you to put in your answers. So here's the following. You have a 20-minute duration, or until all the puzzle pieces are gone. Your time starts now. Time's up, everyone. We will be checking that. I will be checking that later this day, and I will send you back your scores. So for the meantime, please, to further your knowledge in integral calculus, let's summarize everything. What have you learned from today's discussion? Can you recap, Mr. Bellio? Yes, we have learned integration by parts, by assigning various parts of it in order for us to get the answer little by little. Is there anything else, Mr. Alberto? Yes, we also have the tabular integration, which is a part of integration by parts, which helps us further in solving integrals that are cyclical in nature. So, in order for you to help out help out in understanding integral calculus more, and for you to be reminded of the various strategies, create a flowchart that shows the process in finding the appropriate steps when using integration by parts. Use a shorthand paper. You can do this digitally, or you can do this by drawing it by hand. Send it to our Google and please do send it to our Google Classroom. So that ends our discussion for the day. Ms. Zambrano, can you please lead the prayer for the closing of our meeting? Thank you very much, Ms. Zambrano. And for the entire class, thank you and goodbye, and have a nice day.